Hi, this is an Alexa Prize Socialbot. What exactly would you like me to call you?
You can call me Craig Smith, and this is Eye on AI. The Alexa Prize Socialbot Grand Challenge is a competition for university students dedicated to accelerating the field of conversational AI. The challenge is to create a social bot that can converse coherently and engagingly with humans. This year's prize goes to the team from Emory University in Atlanta, Georgia. You just heard their bot introducing itself and asking my name. This week I speak with Prem Natarajan, Vice President of Natural Understanding within the Alexa AI organization at Amazon, who helps administer the prize. We talked about the evolution of conversational AI, its current challenges, and its future promise. Prem talked about the use of neural response generators to seed social bots with natural-sounding, relevant information based on the history of the conversation. I hope you find our conversation as interesting as I did. Prem, can you introduce yourself and tell us how you got to where you are?
Sure thing, Craig. Right now, I'm the Vice President of Natural Understanding within the Alexa AI organization. And it's been sort of an interesting journey coming here. I love what I'm doing now. And in a way, it feels like over the last 28 years, many of the things that I've done have all sort of converged into this experience I'm having now, which includes speech recognition, language processing, machine translation, multimodality. I grew up in this town called Pune in India. It's about 120 miles from Bombay, south of Bombay. And my family is originally from the southern part of India. They speak Tamil. So I grew up sort of in a multilingual world. The local language was Marathi. The languages of instruction were English, and for certain courses, either Hindi or Marathi. So I had to learn those three languages in school and socially. And at home, we were speaking Tamil. So reflecting back, a lot of early discussions between me, my brother, my cousins. Often we'd have things about, hey, isn't it cool? In English, we say, come here. But in Tamil, the sequence changes. We say, here, come. And we had no idea we were talking about fundamental language constructs and how languages manifested in different parts of the world. Anyway, fast forward, I went through engineering school. I did my undergraduate degree in India. I came to the US. And as I was doing graduate study, I was starting to get interested in problems that involve language. And in fact, I worked on handwriting recognition. This is offline handwriting recognition, written on pages, etc., but also online as the kind of writing you might write on pads. And many of these problems use similar techniques. Back then, hidden Markov models were big. So we used hidden Markov models for handwriting recognition. And then we said, gee, why can't we also use them for actually machine printed character recognition? And we started applying that to machine character recognition and ended up creating the first, what was then called sort of language agnostic training methodology for optical character recognition, which means you can just train the same system for different languages and you don't have to write complex language-specific rules, recombine the segments into this language's script and that language's script, etc. That led to interest in speech recognition, which is where a lot of the techniques we were using were originally applied successfully to, especially hidden Markov modeling and Bayesian modeling and all that.
And was that work done at Amazon, or was that when you were still in graduate school?
Oh, no, actually, a lot of this work was at BBN Technology.
I see.
And I should say, so my first professional position was at BBN Technologies. I was there for nearly 20 years, from time I was an individual contributing scientist all the way to when I left there as an executive VP in charge of the speech, language, and multimedia division. So we did speech recognition, machine translation, natural language understanding. BBN was one of the early pioneers in that place, I would say, along with CMU and IBM. It had been part of all the DARPA programs in speech understanding, speech recognition. And I actually credit a lot of my current facility with natural language technologies to sort of the incredible access I had to people I consider to been sort of the giants on whose shoulders we're standing today. People like John McCool, Richard Schwartz, people like Kai-Fu Lee at CMU. So I feel sort of privileged to have had access to all of those people who could sort of synthesize 20, 30 years of learning and share it with so many others like me who were sort of coming into the speech field. Just when things were sort of, in our minds back then, things were getting really interesting because hidden Markov models were making it possible to do speech recognition and language processing at scale. Back then, whatever we thought of as scale, right? So if it is possible to package the excitement we all feel about deep learning today and sort of go back 25 years or 30 years, similar excitement just with a smaller community around hidden Markov models and all that. And so it was great to have that training there at BBN. Anyway, after BBN, I left. I went to academia. I was at USC. I'm still affiliated with the University of Southern California. I still have my faculty position there, though I don't right now, as you can tell, I'm on leave. I'm full-time at Amazon. For the last 2+ years, I've been at Amazon in this role.
And then at Amazon, you brought all of this experience. Did you work immediately with Alexa, or what team did you join with?
Yeah, so I joined directly at Alexa. And I tell you, the speech and language community, in one sense, it has grown a huge amount. On the other hand, it's still a small world. So many of these people that I came into Alexa and started working with were either people that I had worked with before in the same organization, or they were people that had all been my collaborators or teammates on various DARPA, IARPA projects or NSF-funded projects, etc. So many of the leaders that I continue to work with here, Amazon, the sense of community goes back for the last 20 years.
We're going to talk about this year's grand challenge for the Alexa Prize, but can you give us some background on how conversational AI has developed and how it has kind of been slow to develop beyond pre-programmed intents and that sort of thing?
So one simple view of conversational AI is that we're stitching together a few different technologies, right? Speech recognition, intent slot-based natural language understanding, mapping that into a set of actions that you can take, and then executing those actions. But even getting that, what seems like a relatively straightforward architecture to work, actually took, I'd say, a good 20 years beyond when we were able to get speech recognition itself to work relatively at scale. And part of the reason for that, Craig, is that a lot of the ways in which speech was working back then put constraints on the kind of experience that you could deliver, right? So you could get great performance with a close talking microphone. You could get reasonably good performance with clean signals on a telephone. But if you were in a noisy environment or you were at any distance from a microphone, then performance started dropping off dramatically. And so fast forward to 2014 when Alexa was launched, my personal take on it is the major barrier that was broken was that of far-field speech recognition, which is that I can continue doing whatever I'm doing in my daily life as I go around my daily task. But now I can just talk to sort of the environment and the environment responds to me or talks back to me. That back then, having been in this field all those years, I was pleasantly surprised by. I said, gee, they got that to work. That's amazing. So in terms of how conversational AI has improved, I like to view conversational AI as sort of the experience of conversational AI, as the experience of talking to an intelligent agent. And in terms of that experience, I think a major change was this far-field speech recognition. Then the next thing that immediately comes about is how do you start scaling this? Because it's a hit. Lots of people are using it. People have a lot of expectations from it. They want to use it in different ways. So the first thing you adopt, of course, is what I think of as a defect reduction mental model, where you're saying, let me start understanding the various ways in which I'm underperforming and start making sure that I learn quickly from customer signals to improve performance in that way or to fill functionality gaps. But you also step back a little bit and say, as I synthesize all these observations I have from these different defects I'm looking at, what are some systemic or architectural things that I take away? So for example, one takeaway is that as you're launching more and more features, if you have to train models for every new feature that you're launching. And then you have to get annotated data for that's a huge expense. And that's also slow. You're not doing things as fast as you can to help meet customer expectations. So we start asking ourselves, so what's the fundamental science challenge there? We said, gee, if only we could take all these models that we already have and transfer some of that learning onto new features, that would accelerate us. And actually, gee, come to think of it, if I can do that, then I can also take models from fundamentally data-rich environments or data-rich applications and provide a satisfying experience for fundamentally data-poor environments or where it's difficult to get data. And that's where deep learning sort of comes in as this rising tide that lifts all boats, whether it's transfer learning or pre-training. It's turned out to be this amazing accelerator of both the scientific progress and engineering progress. Specifically, if you take some of these pre-trained transformer-based architectures, we can start with those, use very little data, and launch something that's at the same level of performance that would have taken a lot of training data to do. But we also look at it in a different way and say, but if I really want to still fix the defects in here, how do I focus the data that I'm looking at on those gaps? And that's where active learning comes in. And turns out active learning works really well in combination with deep learning. So all of these kinds of things, that's, I'd say, that second technology vector that's driven conversational AI forward. So even though to some extent we think of it as component-based technologies, whether it's in the sense of being able to transfer learning from one area of application to another area of application, or it's from the perspective of carrying context through. Like, for example, I say, what's the weather in Boston today? And I get an answer. And then I ask, what about tomorrow? The system knows to carry the context over, which is Boston. Or I then say, and what about Los Angeles? And now it knows carry the context that is today, but that it's about Los Angeles today. These kinds of things all start becoming easier with deep learning. So even though in some sense these things might be componentized, we're already starting to build a scaffolding that is tying these things together, laying the foundation for what I think is the next thing, which is more and more integration of these components.
And on the learning part of it, what you're saying is that initially they were components and each component had its own set of algorithms to do different things. And with the rise of deep learning, they're being put into an end-to-end system. Is that a way of describing it?
I think, roughly speaking, that's true. The additional nuance I'd add there is, even if they're still components, the fact that there is a common methodology that they all embody, which is deep learning, makes them more able to work together and makes it more efficient for us to configure them, and also lays the foundation for us to get deeper integration of these things into more end-to-end training regimes.
With a deep learning underpinning, there's an expectation that these systems will become increasingly conversant because they will learn not only what they've been trained to do in the lab, but they will learn through their conversation with users. Can you talk about how much actual learning there is right now with Alexa and other conversational AI models? Specifically, I'm interested in what happened with Tay at Microsoft. And from my understanding, that kind of put the brakes on online learning for these systems. So the training and the learning is much more controlled. Can you talk about that?
So first, about learning from the user itself, I'll motivate it with a very simple example. How can we learn directly from the user to extend the capability of conversational voice assistants like Alexa? One thing that we've already done and that's out there in production, benefiting millions of utterances every week, is the thing that we call automatic learning of equivalence classes. So imagine that you come to Alexa and you say, Alexa, play SiriusXM Chill. And the first time you ask it, nobody ever taught it what SiriusXM Chill is. So Alexa comes back and says, look, I'm sorry, I don't know what that means. And maybe 100 people have that experience, and maybe some fraction of them, 10, 5, follow up immediately to say, Alexa, play SiriusXM channel 53. Through this behavior, without any human in the loop, without anybody annotating anything, you can actually do a reasonably confident inference that SiriusXM Chill and Channel 53 are probably the same thing. Once you learn that, the next time somebody comes and says, play SiriusXM Chill, you can automatically translate that into play SiriusXM Channel 53. And actually, you can even test it without a human in the loop. So now imagine that you play SiriusXM Channel 53 and the user listens to it for a while. That gives you confidence that you did the right thing. But let's say you played it and the first few users you play it to all sort of say, stop and try to change it. That gives you some signal that maybe that's not the right thing that I did. So it's not just in my mind the content that you're learning from, but you're learning from other signals the customer is sending you in order to make sure that you're learning the right things that are useful. Now, coming over to systems that were learning online in an unconstrained way, you're right. There are examples where that kind of learning goes awry, especially because what happens is people can launch what you might think of as, coordinated attacks or adversarial attacks on the model, where if a lot of people group together and decide to teach it the wrong thing, then it learns the wrong thing. And then sometimes that wrong thing is an offensive thing. At the same time, online learning is a very powerful learning mechanism. So the question we ask ourselves is, how do we do this right? How do we do this so that it's robust to this kind of exploit? And there are multiple things that we're doing. One is that you can, on the output side, a lot of this is around the generation piece of it, right, Craig? Where you're generating your response and you want to make sure the response you're generating is appropriate. It's both accurate, it's also appropriate, and it's not offensive. So the first obvious thing to do is to try to build classifiers that detect either toxic messages or offensive messages or offensive patterns, things like that. And you want to learn these at scale, because if you just write rules, it doesn't scale. And that's one of the things we have done and that we do put in production. A second thing that I think is even more exciting from a machine learning perspective is a lot of our research today is focused on teaching a system how to do something and how to do it better. But these kinds of examples that you just brought up with online learning that got out of control, we also want to be able to teach the system what not to do. So there are some recent proposals, and we're looking into ideas like these as well, about can we provide data sets that tell the system, hey, this is what I would like you not to do. In a colloquial way, instead of likelihood learning, maybe unlikelihood learning. So basically avoid doing things like this. Just like with giving it positive examples, it can generalize from those positive examples to provide other positive examples. The goal here is that by providing negative examples, it can generalize from those negative examples to avoid a much broader class of negative examples. But, going back to your question, I think online learning, crowdsourced learning remains a very valuable source of learning, but we also recognize the need for research in that area. So what we've been trying to do is also provide crowdsourced data to academic researchers, whether it's through the Alexa Prize or through other channels. Recently, for example, we released the largest knowledge-grounded conversational data set that's publicly available. It has over 10,000 conversations, I think maybe 250,000 conversational turns, maybe something like 5 million words. It also includes the knowledge sources that were used to produce responses. All of this allows people to research and find better and safer ways of combining online learning's benefits, but also protecting us from the downsides of online learning.
And what we're talking about right now is task-oriented dialogue. You ask the model or the virtual assistant to play a song or to book a hotel reservation. But there's another, when people think of conversational, they really think of chit-chat, right? Of having a conversation where the agent can respond to natural language and weave in knowledge from a knowledge base. How far are we on that road? And is that what the challenge is about this year?
The Alexa Prize Challenge is very much about chit-chat or social conversations. There are different ways of describing it, open-ended conversations or conversations without a particular goal in mind. That's the distinction I believe you're making between task-oriented dialogue systems. That is the focus of the challenge. And there are some implications in terms of the technologies that we just talked about. a very important implication is that in social conversations, a lot of the responses that you need to generate are really mostly conditioned on the history of that conversation. Whereas in task-oriented conversations, you're often having to interact with dynamic information. So if I ask you, what's the weather today? You cannot answer that question just based on the conversational history. You have to look up some information, and that information is dynamic. So typically for social conversations, we blend both of these things because you want to talk about current events. You have to blend these two things. But the technological implications come about in the sense that when you have end-to-end systems that are being learned, they're typically limited to where you can generate a good response based on the conversational history. Whereas if you have dynamical information that becomes part of the conversation, then building purely end-to-end systems becomes much harder. That's beyond the state of the art right now.
When you have a conversation, oftentimes the speaker, the interlocutor, will draw on their knowledge and insert that knowledge into the conversation. Right now, when I talk to a virtual assistant and I ask it a question, it does not answer conversationally, usually. It will give me the source that it's found, and then it will read from that source, which is very different from a conversation. I mean, if I say, did George Washington really chop down a cherry tree? The agent will search maybe Wikipedia or some biography and will say, this is what I found, and it'll read me the entry. So when you're talking about blending the two, it would do that. It finds the source, it finds the information, but then it has to synthesize that into the conversation in a seamless way. How far are we along that road?
Actually, we've seen significant progress on that, especially over the last year and a half, 2 years, I would say, Craig. Let me give you an example from the Alexa Prize. For this year's prize challenge competitors, the university teams participating in it, in addition to the usual access we provide to our speech recognition, natural language understanding, etc., we also put out a neural response generator. So basically, the neural response generator, going back to what you said, it might find something, whether it's doing retrieval-based or just looking at conversational history. It might find something, whether it's a topic or particular fact, that it uses to seed what response the neural response generator will generate. But it's not reading out verbatim what it found. And so it's using at least two things to condition the response. One is the conversational history so far, plus some factoid or some other attribute that it might have gotten from some other source, and then using those to generate a response that is then played out to the user. This year's Alexa Prize contestants have used this neural response generator, and we saw a very nice improvement in how users responded to it and how much the user satisfaction went up because of the naturalness of those answers.
Going back to the learning, when you say the signals that the system's getting, if you yell at the system to stop when it's halfway through its response, that's obviously a negative signal. If the conversation continues with more questions for a period of time, that's a positive signal. That sounds like reinforcement learning. Is that sort of the underlying learning strategy that you're using once you have the basic conversational framework set?
That is definitely one of the learning strategies that we're using once we've sort of trained a model and put it out into production. You're right that it has a flavor of reinforcement learning. I mean, when you get to machine learning, there's always purists who will say, well, strictly speaking, reinforcement learning is defined in this way. But in sort of the flavor of this being reinforcing the system's behavior by looking at the customer's behavior, customer signals, this is definitely our foray into trying to use customer feedback as reinforcement in the live system. But I should point out, because we're talking about, generally speaking, architectural changes that we're saying, in the context of Alexa Conversations, which is this new conversational experience development environment, where we're using deep learning in the developer environment itself to reduce the amount of data that an experienced developer needs to bring to the table and to reduce the amount of coding that they need to do. We are moving away from the intent slot architecture, Craig. So here, what we're trying to do is we're just extracting entities, other things, and then we're directly trying to predict the actions that the user wants taken. And as part of that process, we're also trying to predict which of these make sense for those actions. And so for that too, the way in which we are training these systems in simulated environments, etc., has a flavor of reinforcement learning.
And watching the progress through the prize and progress within Amazon, is it a situation where there are classes of algorithms and everyone understands what the components should be, and it's a matter of tweaking parameters or improving training data sets or something like that to inch down error rates and inch forward success rates? Or are you seeing completely new approaches that are surprising everybody?
So 3 things there. One, obviously in the very immediate term, right, as you're deploying things, you always want to have a portion of your work that is focused on incremental improvements of the experience, because that experience is already out there. You want to reduce defects in that experience, and you're doing that. The second thing you're trying to do is to expand the scope of experiences that can be developed. And that's where what I just mentioned, the Alexa Conversations development environment, where we're using AI in the developer environment itself to help developers develop richer experiences with less effort. On the third one that you're talking about, surprising new developments, unfortunately, the one that I really want to talk about, I can't talk about right now, but we can talk about in October when we launch it. But I'll just give you a flavor of it, which is, I talked about this learning where we're learning equivalence classes directly from the user. What we want to do is to go down that path, but essentially on steroids, like how to go down that path even further. The details are not yet ready for sharing, but we're planning to do a more public sharing of that work this fall.
And in a research paper sort of way, or
No.
With a product release?
Yeah, as a launch that we will actually demonstrate, and we will also launch to our users so that they can try it for certain use cases. This goes back to our overall approach, Craig. I mean, we don't announce just technological advances. We usually announce things that our customers can use. So because of that culture, we often don't talk about technology advances that are in the lab, because what we really like to talk about are, here's something you can go use, and it's driven by this innovation. So yes, it will be something that people can use with their favorite Alexa device.
Wow, wonderful. One of the things I'm interested in is the possibility of using conversational AI in education, in online education. And Alexa, with the installed base that it has, is the perfect vehicle for that sort of thing. Is there talk within Amazon about developing programs specifically for education that can be delivered through Alexa?
So as you know, we don't talk about specific product roadmaps, etc. But having said that, I mean, obviously, education is not just something we want to do, but we can see that our customers want it. They want to use Alexa. There are skills already that, for example, you have language learning skills on Alexa, right? So to some extent, there's already some education component that's available on Alexa. And I think it's fair to say that given the amount of customer interest there is in it, obviously we talk about it. We want to figure out the best ways to serve our customers, and we will continue to index on that vector. But you're absolutely right. Education is of high customer interest, and therefore it's of interest to us as well.
Yeah. And particularly with regards to advances in conversational AI, because that's what you need. You need engagement in a conversational context for it to hold people's attention. I mean, it can't simply be question, answer. When are the results of the prize announced?
The results of the prize will be announced in about 3 weeks. I definitely can share the winner. It's the Emory team from Emory University. Each of these years, we've had a new team win, which is sort of satisfying to us because it feels like we are creating a awesome talent pool out there, which was always one of our key goals with the Alexa Prize competition. And this year's winner is the Emory team from Emory University.
And can you talk about the winning submission, why it won, what it performed?
Yes. What I'll say about the Emory system is I don't want to steal their thunder, but I will at least share one thing that from my observation was very interesting, and I think it blends both technological advance and a focus on the user experience and the customer experience. So the novelty that's caught my attention is this thing that they call personal experience-oriented dialogues. Basically, their social bot tries to detect a set of fine-grained topics that are expressed from personal experience, as in the dialogue context, etc., and then uses that to sort of gently switch the way the responses are generated to stuff that feels natural and conversational and appropriate. And I think they've done a very nice job of making sure that the focus on the personal experience as expressed through the dialogue context, and then sort of using that in a way to nudge the responses that are being generated in a direction that is very satisfying to the user.
And the challenge is 20 minutes, is that right? Do they have one shot, or is it 20 minutes each with each of 5 judges? I mean, how do you do that?
So these 20 minutes are averaged over many sessions. The reason the 20-minute is sort of our grand prize, and nobody has achieved that yet, it's very challenging. It's a little bit of a moonshot, but it's averaged across many different sessions. So it's not enough for them to get lucky and have one 20-minute conversation with one person. It's averaged across all of their sessions.
But each conversation is 20 minutes, and then you score that 20 minutes on various...
Each conversation is whatever length the judges take it to before they say, this conversation has ended. It's not worth continuing this conversation because we're not hearing anything new, or it's not keeping up with us anymore. So both the quality rating of the conversation and the duration of the conversation, they're independent variables.
And then how many sessions does each team get that are then averaged?
So just in terms of the overall competition, right, there is months during which the university's social bots are directly accessible to Alexa users. So if you have an Alexa device, you can go and say, Alexa, let's chat. And Alexa will connect you randomly to one of the social bots. We don't tell you which social bot it is for a variety of reasons, but also to make sure that the system can't be gamed, because we're also looking at user feedback. And so you get months of interaction. And in fact, the social bots are among the top 10 skills on Alexa. So a lot of people engage with them, and some of those engagements are surprisingly long, and people seem to find them satisfying. Then we go into this judged competition phase, which is the finals, where it's a 4-day event with multiple sessions each day. And then there's a whole panel of judges, and all the judges get to interact with all the social bots. We don't tell them which social bot they're interacting with. They just go in and they interact with a bunch of different social bots. Though, of course, over time, the judges get to know, based on the behavior of the bot, this must be that same bot. They still don't know which team's bot it is.
Yeah.
And so the final winner is judged on the basis of that judging, which is over 4 days and multiple sessions each day. But the selection to the finals is based on their performance over 7-day periods, as based on the feedback that we get from Alexa users. So in fact, Alexa users are among the most important judges for this competition because they decide who gets in the finals.
Yeah, that's really interesting. Yeah.
It's also exciting, Craig, because can you imagine being a university student and having access to not just state-of-the-art technology, speech recognition, NLU, etc., being able to focus on just the thing that you want to do, which is the dialogue system and the conversational AI on top of all that state-of-the-art technology, but also live, real-world situation where you're getting to interact with real-world users who are interacting with your systems and giving feedback.
Yeah, it's amazing.
Yeah, sometimes I wish I could go back 30 years,
Yeah. And do you have metrics on how many interactions there are over the course of the competition that you've had, that each system has had, however many hundreds or thousands of conversations?
Oh, yeah. And you have it right. It's around that many tens of thousands of conversations, approaching hundreds of thousands of conversations.
Wow. And the winner, Emory's team, Amora, were they incrementally ahead of the competition, or is there a big gap between them and the second place team?
Caveating it with the fact that the finals, the last sessions happened yesterday. And so these are preliminary numbers. The gap is substantial.
Oh, wow. That's fascinating. Are these models still accessible on Alexa, or have you taken them down now that the competition's over?
They're still available. You can go say, Alexa, let's chat.
And it'll direct you to one of them, or do you now give it to Emory?
No, it'll direct you to one of the finalists right now.
This is kind of a side question. Is there a directory somewhere of Alexa intents or Alexa programs or something? I'm sure I'm revealing my ignorance. There's an Alexa in the house. To be honest, I use it to ask what the temperature is outside and periodically some obscure fact when we're having a dinner table conversation. There's a lot to explore there, and I've never really explored it. Is there a way that people can find all the different things that they can do through Alexa?
Yes. So there are 2 or 3 channels. One is explore through the Alexa app.
Yep.
The Alexa app gives you a lot of information about everything that's available in Alexa. In fact, if you go to the app, there are things that say things to do, recommended things, etc. So it's a very rich source of information about all the capabilities on Alexa. But my favorite way of finding out about Alexa is to just ask it to do something, because if it does, awesome. And if it doesn't, I guarantee you, if there are enough people wanting that thing, it will do it eventually, because that's how we learn also what it is that we need to do more of. In other words, Craig, we don't want customers to learn Alexa, right? We want Alexa to learn how to serve customers. So we don't want to give a manual, because in our minds, Alexa is constantly improving. It's constantly adapting to you. It's constantly serving you better. So it's not this sort of static in time thing. We talked about education a few minutes ago. I just wanted to share an anecdote that comes to my mind because it ties in with this notion. My youngest daughter is the power user of Alexa in our house. And when she's doing homework, she'll be sitting at the dining table talking to the Alexa that has a screen on it. And it's become sort of an integral part of her doing homework. She's doing something on her homework. If she's stuck, her instinctive thing is to ask Alexa, especially if she's writing essays on Millard Fillmore. But one day she was really surprised. I told her that Alexa can do math. So she went and asked Alexa in her mind what was this really complicated math question. And Alexa came back instantly with that answer. And she was just... that was a very satisfying moment for me. And she looked at me and said, "Dad, your team did that?" I said, "Yeah, sorry."
That's wonderful. That's wonderful, yeah. Is there anything I haven't asked, Prem, that you'd like listeners to know?
Yes, just in terms of our approach to this whole area, Craig, I think as you well know, there's technology first approach to it, an experience first or a customer first approach to it. We very firmly focus on the second one, but we are informed by things that are happening elsewhere. So we look at these chit-chat models. Many have been put out recently, both within the US and outside. And you can go try them out online, and some of them take 25 seconds to come back with a response. It doesn't matter how satisfying in some sense that response is. If it takes 25 seconds to respond, it's not satisfying from a customer experience perspective. But that said, I think there is the seed of tremendous future capabilities in some of these. And both through the Alexa Prize and through internal research efforts, we are focused on trying to make Alexa much more conversational, much more natural, much more intuitive, if you will, and in some cases proactive. So my overall message is, if you have an Alexa, you have an intelligent, growing AI in your home.
I have a feeling that we have talked before. Are you Craig?
Yes, indeed I am.
I thought as much. Glad to see you back, Craig. I am really excited to get to know you better. So, my friend was telling me this really funny story yesterday. He knocked down almost every piece of furniture in his living room because he was so wild while playing this virtual reality video game. Isn't that crazy?
Yeah, that's pretty crazy. It sounds like my son. That's it for this week's podcast. I want to thank Prem for his time and to congratulate Emory University on winning the Alexa Prize. The team is a diverse group of graduate and undergraduate students from the university's Natural Language Processing and Intelligent Information Access Labs. If you want to know more about today's episode, you can find a transcript of this show on our website, Eye on AI. We love to hear from listeners, so get in touch with any comments or suggestions. And remember, the singularity may not be near, But AI is about to change your world, so pay attention.